Okay, we're just going to do a few examples with explicit and recursion. So for the explicit formula, that's this one that's right here. Recursive is right here. You know the recursive always has two parts. So if I want the recursive formula, I'm literally going to plug in, and you're told this is arithmetic, so you know that we're either adding or subtracting the same amount. So in this case, I'm adding 4 each time. So my common difference is 4. So then I just go to my formula, whoops, and I say a sub n is equal to a sub 1, which is 2 plus n minus 1 times 4. So a sub n, I distribute 4n minus 4. So a sub n is equal to 4n minus 2. There's my explicit formula. For my recursive formula, I always write my first term, which in this case is 2. And then a sub n is equal to a sub n minus 1. You leave those there because it's supposed to be speaking generally. Let me put plus our common difference, which is 4. Okay, next example, write the first 6 terms of the sequence. Okay, so you can see to go from 3 to 13, I'm adding 10. I add 10 again to get to 23, add 10 and 10. So this is arithmetic. So my common difference is 10. Okay, so if I want the first 6 terms, then I have so far 1, 2, 3, 4, 5. Then I just add 10 again, and I will get the next one. Okay, so a sub 6, if I add 10, is 53. But I want to practice writing recursive and an explicit formula. So you know that for a recursive, it's just like this. A sub n is equal to a sub n minus 1. Remember, those stay. Those are fixed. The only thing you put in your recursive formula when it's arithmetic is plus d, which in this case would look like this. So a sub n is equal to a sub n minus 1 plus. Now, if I want an explicit formula, you know that that's a sub n is equal to a sub 1 plus n minus 1 times d for an arithmetic sequence, and that's what this is. So I have a sub n, a sub 1, my first term is 3. My common difference is 10. I distribute my 10. Combine like terms. Okay, 3 and negative 10, and I have 10n minus 7. Okay, let's finish with another example. Write the first 5 terms, and it's given sort of like in a recursive form. Well, it is in a recursive form because we see our first term and our formula for finding each term given the previous term. So if they want the first 5 terms, that means they want a sub 1, they want a sub 2, a sub 3, a sub 4, a sub 5. I already have this one. So you know that for a sub 2, if I literally follow the formula, it's going to be 2 times a sub 2 minus 1, which means that a sub 2 is equal to 2 times a sub 1 minus 1. And a sub 1 is 4. So that gives me 7. If I want a sub 3, it's 2 times a sub 3 minus 1, which becomes, you write it over here, a sub 3 equals 2 times a sub 2 minus 1. And then a sub 2 we know is 7, so it's 2 times 7 minus 1, which is 13. A sub 4. And I'm going to stop writing this. It's just going to be 2 times a sub 3 minus 1. So that's going to be 2 times 13 minus 1, which ends up being 26 minus 1, 25. A sub 5 is equal to 2 times a sub 4 minus 1. So a sub 5 is equal to 2 times 25 minus 1, and that's 49. Now just make sure you make a list. So I have 4, 7, 13, 25, 49. And those are my first 5 terms.